Indirect measurements allow you to use the properties of similar triangles. Remember that similar triangles are triangles that have the same shape but a different size. And when I say the same shape, what I mean is they have the exact same angle measures, because this is a triangle and this is a triangle. They're the same shape, they're same triangles. I guess I should say they're not really quite the same shape. They're both triangles, but like this one is a right triangle, this one is an acute triangle. When we say same shape, that means the angles have to be the exact same measurements. Meaning, if this angle right here was 37 degrees, this angle has to be 37 degrees. If this is a right angle, this has to be a right angle. Okay? So it's literally all of the angles are the same, it's just that the side lengths are increasing. Okay? With shadow reckoning, two objects and their shadows form two sides of similar triangles. So in this example, they're talking about a statue and a tourist. So we have our picture of a statue and a tourist. We're using our shadows to help us figure out the height of the statue here. So we know the tourist is 64 inches tall and gives a shadow of 32 inches. We know that the statue has a 34.5 inch shadow, and we need to find the height. So what we're doing is we're creating these similar figures with real life examples in order to set up a proportion and solve. So I always do small to big in my proportions. So small would be 64, the corresponding side would be the h, small would be the 32, the corresponding side would be the 43.5. And then we would do our cross products. 32 times h is 32h, 64 times 43.5 is 2,784. I divide both sides by the coefficient of 32 and I get 87 inches. So the statue is 87 inches tall. On this example it says, suppose a bell tower cast a 27.6 foot shadow at the same time a nearby tourist casts a 1.4 or 1.2 foot shadow. If the tourist is 6 feet tall, how tall is the tower? Sometimes we'll have to draw our own pictures for this. So this example would be, here's my bell tower. Here's my tourist. I know that the bell tower has a shadow of 27.6 feet. The tourist has a shadow of 1.2 feet. I also know the height of the tourist is 6 feet, and I don't know right here. So again, we're trying to make these similar triangles. We're using right triangles. Okay? And when we do this, now that we have our two similar triangles, I can set up my proportion. The small to the big. So my small is 6 over the corresponding on the big is x. 1.2 is my small. The corresponding on the big is 27.6. We can do our cross products. And that would be 1.2x is equal to 6 times 27.6 is 165.6. Divide by the coefficient on both sides, and I would get 138, and it is feet we are talking about, so make sure you always label at the end. So the new part of today, this is just like yesterday, the new part is you might have to draw a picture to kind of understand where our numbers go for our corresponding shapes. surveying methods. So surveyors use similar triangles, but their methods does not always involve shadows. Notice in example 2 that it is possible to measure 3 sides of the triangles directly. So it says in the figure, triangle STU is similar to triangle VQU. That's how you would read this part. Triangle STU is similar to triangle VQU. Find the distance across the pond. So when I'm looking at this, I need to find my corresponding parts. I know that 20 is corresponding to the X. If you have a hard time deciding that, kind of use those angles. I know that here it's the right angle going outward, and it's the longer side here than the 10. So when you look at it in the picture, it's longer here than the 16. These are my other corresponding parts of the triangle. Okay, so what they really did is they took this triangle that looks like this and they turned it upside down and made it bigger. Okay, once you have that, we can set up our proportion. So we had our bigger one to our smaller one here. They did the big is 16 over the small is 10, so that means I go bigger to smaller on the other part. I had big to small. Then they did their cross products and solved and found that it was 32 meters. On this example, it says, in the figure, triangle QRS is similar to triangle URT. Find the distance of the cabin to the mess hall. And on this one, we have our similar figures here. I know that X and 60 are corresponding parts, and 46 and 138 are corresponding parts. Again, what they did is they just took it and they rotated about the point. So they rotated it around over. So what was on the bottom here, like this line is on the bottom here, and when I flip it over, that line on that marker is now on the top. Okay? So that's how you can kind of think through where your corresponding parts are. We go to set up our proportion. This one's my small, this one's my big. So I'm going to start with any of the numbers from the small, doesn't matter. So 46. The corresponding part on the big is 138. On the small, corresponding part on the big is X. And we do our cross products. 46 times X is 46X. 138 times 60 is 8,280. I divide by my coefficient on both sides, and I get 180 yards. So from the cabin to the mess hall, it's 180 yards. Okay. On the homework, there's some tricky problems, so if you need any help with that, just let me know and I'll be glad to help you.